All right, so now we're going to use the extreme value theorem on a trig function. So we check sign. Sign is continuous. And we have our closed interval 0 to pi. So we know we can use the extreme value theorem. So now if we plug that in our calculator, we do sine of x, make sure our mode is in radians. Perfect. So we have sine of x, and then again we go to window, and we enter in our domain. So there we go, 0 to pi, and then hit zoom 0, and it gives us our picture. But we can already have graphed this by ourselves because it's just sine. So we knew it's going to go from 0 to pi with pi over 2, right? And it's going to do this shape. But the calculator just tells us that we are correct. So we know we're going to get a max or a critical number at pi over 2 on this. So let's take our derivative and see what we get. So x prime of x is equal to cosine of x. And then we take our cosine of x and set it equal to 0. So on that interval from 0 to pi, we know that x will equal to pi over 2, which will give us a cosine of x equal to 0. So that works perfectly. We only have to worry about that interval, which is 0 to pi. All right, and then we do the same thing before. We plug in our 0 and our pi, and we put our one critical number that we have for this one. And then we check those values. And again, we already know the values, but we're going to keep it simple. So if we hit trace and 0 and consistent, we get 0. Pi will give us the same thing. So if I hit trace second pi, you see it's the same as 0. And then the pi over 2 we know is our highest, which we know is 1. Oops. Second pi divided by 2, and it should say 1. Perfect. And so we know this is a min, this is a max, and this is a min. So we have an absolute max of 1 at pi over 2, and an absolute min of 0 at 0 and pi. And so there's no difference with your trig functions. They work exactly the same. Same rule for the extreme value theorem. Thank you.